Hello students, welcome back to Enappan Academy of Chemistry. In the previous lecture, we started analyzing the repeated question models in the past 25 years NEET papers in the topic equilibrium from chemistry portion. We have discussed problem models under 3 headings in the part 1 lecture: equilibrium constant, Le Chatelier principle and acid-base strength. In this lecture, part 2, we are going to look at problem models in the remaining 4 topics: dissociation constant, pH, buffer and solubility. We can move on to the problems now. Look at the first problem under the topic dissociation constant. The pKb of dimethylamine and pKa of acetic acid are 3.27 and 4.77 respectively. The correct option for the pH of dimethyl ammonium acetate solution is, in this question, the pKb value of the base and pKa value of the acid are given. You are asked to calculate the pH of the salt. The salt dimethyl ammonium acetate is formed by combining the base dimethylamine and the acid acetic acid. This salt is a type 4 salt. Okay. The base is also a weak base. Dimethylamine is a weak base. Acetic acid is also a weak acid. When you combine a weak base and a weak acid, you get a type 4 salt. For type 4 salts, the formula for calculating the pH is equal to 7 plus half pKa minus pKb. This is the formula. Okay. So in this question, pKa and pKb are given already. Directly you substitute the values and you will get the pH answer as 7.75. That is, option 3 is the correct answer. If you substitute the numbers, you will get this answer. Okay. Coming to the next question. What is H plus ion concentration in moles per liter, that is molar, of a solution that is 0.2 molar in sodium acetate and 0.1 molar in acetic acid? Ka value is given. Here, salt sodium acetate concentration is given. Concentration of the acid, acetic acid, is given. Ka value is given. You have to find the H plus ion concentration. This is a buffer, as you can see. This is an acidic buffer. Weak acid, acetic acid is a weak acid, plus its salt of a strong base. Acetic acid, sodium hydroxide salt is sodium acetate. If you mix sodium acetate and acetic acid, you get an acidic buffer. The equation to calculate pH of a buffer is Henderson equation, which is pH is equal to pKa plus log concentration of salt divided by concentration of the acid. Okay. If you substitute the values, the pH value you will get. Okay. From pH value, you have to calculate the H plus ion concentration. H plus pH is equal to minus log concentration of H plus. Now we got the pH value. So H plus is equal to, you take anti-log of minus pH. Okay. If you do the calculation, you will get option D as the correct answer. Our next topic is pH concept. The most common question under pH concept is, you will be provided with mixtures of acids and bases. You have to calculate the pH of the final solution. What is the pH of the resulting solution when equal volumes of 0.1 molar sodium hydroxide and 0.01 molar HCl are mixed? Okay, here you have to observe the question. First, you see which is in excess, NaOH or HCl. It's given equal volume. Okay, volumes are equal, but the concentrations are different. NaOH concentration is more, it is 0.1 molar. HCl concentration is 10 times less, 0.01 molar. Okay, therefore, which is in excess? NaOH is in excess. So, the resulting solution is going to be alkaline. Okay, first you decide this which is in excess, then you apply this formula. In this case, we have to write OH minus ion concentration. See, if acid is in excess, then you have to write H plus concentration is equal to, you have to write the formula that way. Here NaOH is in excess, so I am writing OH minus ion concentration is equal to M1V1 minus M2V2 divided by V1 plus V2. Here M1 is the concentration of the species which is in excess. Here NaOH is in excess, so M1V1 corresponds to sodium hydroxide. M2V2 is the molarity and volume of HCl. Here what is given? Volumes are equal. The question says that equal volume, so V1 is equal to V2. Therefore, the formula becomes, can simplify the formula as, you write V1 is equal to V2, V2 is equal to V. Then you get M1 minus M2, you can take V as common, divided by 2V. So, the formula simplifies as M1 minus M2 divided by 2. Very simple. So, 0.1 minus 0.01 divided by 2. If you do that, what you will get? You will get the OH minus ion concentration. What is asked here is the pH. Okay. So, from OH minus ion concentration, if you do the calculation, you will get it as 0.045. From OH minus concentration, you can calculate POH, which is log of minus log of OH minus ion concentration. If you do that, you get POH as 1.35. You know pH plus POH is equal to 14. Therefore, from POH you can calculate pH. 14 minus POH, that is 14 minus 1.35. You get the answer as 12.65. So, here for this question, third option is the correct answer. Okay, you read the question carefully. What is asked? pH or POH, H plus ion concentration or OH minus ion concentration. This is where students they are likely to do mistakes. Okay, in a hurry, you will just look at the concentration values because you are familiar with the formula. So, your familiarity will make you do mistakes. Okay, so read the question very carefully before answering. Now, we can go to the next question. Which one has the highest pH? This is a straightforward question. Okay, see, highest pH means the solution should be alkaline. Okay, look at the four options. Which solution will be alkaline? First, look at option D. Option D is a salt. Sodium nitrate is a salt of strong base and strong acid, NaOH and HNO3. So, the solution will be neutral. Okay, pH will be equal to 7. Look at this option C. This is a salt of weak base NH4OH and strong acid HCl. Okay, so here solution will be acidic. pH will be less than 7. What is the question? Highest pH. Option A and B both are salts of weak acid and strong base. Option A, CH3COOH, KOH. So KOH is a strong base, CH3COOH, weak acid. Similarly, option B also, H2CO3, carbonic acid is a weak acid, sodium hydroxide is a strong base. Both options A and B will result in alkaline solutions. So pH will be greater than 7 for both A and B, alkaline solution. Within these two, which one will be more alkaline if you see? Sodium carbonate, because 1 mole of Na2CO3 will release, if on hydrolysis, it will release 2 moles of NaOH, whereas CH3COOK will 1 mole will release only 1 mole of KOH. So the correct answer is option B. Okay, sodium carbonate. Coming to the next question. Following solutions were prepared by mixing different volumes of NaOH and HCl. Okay, of different concentration. Here volumes are also different, concentrations are also different. Which one will have pH equal to 1? That's what you have to find out. Okay, pH equal to 1 means acidic. Which combination will give an acidic solution? We will try to rule out any option. Look at option D, equal volume, 100 ml, 100 ml. Concentrations are also equal. So what will happen? HCl, NaOH will neutralize and you will get a solution, neutral solution, pH equal to 7. So this option is ruled out. You need not do the calculation for this. Look at the remaining 3 options. The remaining 3 options A, B and C, HCl volume is more. Okay, concentrations of HCl and NaOH are same, but in all the 3 options, HCl amount is more. So all 3 will result in acidic solutions because HCl content is more. So there is no way you have to do the calculation for all the 3. Okay, on doing the calculation, you will see that for option C, you will get the answer pH will be equal to 1. Okay, so here how you have to do the calculation? Here in all these cases, HCl is in excess. So when you write the formula, you write it as H plus concentration is equal to M1V1 minus M2V2 divided by V1 plus V2. Here volumes are also different. So here M1V1 you have to take the concentration and volume of HCl because that is in excess. If you substitute the values, you will get H plus concentration. From that you calculate pH, which is equal to negative logarithm of H plus ion concentration. Next common topic is buffer, which will make a basic buffer. 4 different combinations of acids and bases are given. What is a basic buffer? Weak base plus its salt of a strong acid. Okay. As you are familiar with the formula M1V1 that we have seen in the previous page, you will immediately jump into doing the calculation. Okay. My suggestion is some problems can be solved logically, but time management is very important in NEET exam. So try to approach the problem logically, but don't spend too much time on that also. Look at this question, look at the options. First you locate which options are having this combination, weak base and salt of a strong acid. Okay. Option A, NaOH is a strong base, so ruled out. Option B, again NaOH strong base, weak acid, ruled out. Option C, weak base, strong acid. Option D, again strong acid, strong base. So option C is the correct answer. No need to do any calculation. So if you mix HCl and NH4OH, you will get NH4Cl, salt of strong acid you will get. So weak base, ammonium hydroxide plus NH4Cl. Okay. Move to the next question. A buffer solution is prepared in which the concentration of NH3 is 0.3 molar. Base concentration is there. Concentration of NH4 plus salt concentration is given. Kb value of the base is given. Okay. What is the pH of this solution? Okay. So this is a very straightforward question. Again, you have to apply Henderson equation. In this case, POH is equal to PKB plus log concentration of salt divided by concentration of the base. Okay. If you apply this equation, you will get POH value. What is asked here is the pH. Okay. pH is equal to 14 minus POH. You remember, Kb value is given, not PKB. First you have to find PKB. PKB is minus log Kb. So first you find PKB, then you substitute here. Salt concentration means NH4 plus concentration, you substitute here. And ammonia concentration 0.3, you have to substitute here for base. And this is for salt. And PKB you have to calculate and substitute. You will get POH, and from POH you can calculate pH. If you do the calculation, you will see option B is the correct answer. You will get the answer as 9.43. Okay. Look at the next question. This is also based on Henderson equation. This is a conceptual question. The rapid change of pH near the stoichiometric point of an acid-base titration is the basis of indicator detection. pH of the solution is related to ratio of the concentrations of conjugate acid and base forms of the indicator by the expression. They are actually directly asking you Henderson equation. So we write it in the usual way. pH is equal to, here instead of acid or base, you just write indicator, pK indicator plus log concentration of the salt by concentration of the original indicator in the acidic form. If you rearrange it, you bring pKin this side, you get pH minus pKin is equal to log salt form In minus divided by acid form HIN. So option D is the correct answer for this question. Okay. Let us move on to the next topic, solubility. In solubility topic, you get two types of questions. Either they will give you a set of salts and ask you to arrange the salts in the order of increasing or decreasing solubility, or you get numerical problems where solubility is given, you are asked to calculate the solubility product, or vice versa, or they will give the value of solubility product KSP and ask you to calculate S. These are the two problem models under the solubility heading. Look at the first question. Identify the correct order of solubility in aqueous medium. Copper sulfide, zinc sulfide, sodium sulfide. These are given. Out of this, you know very well that sodium sulfide is the most soluble among the three salts. Okay, it's an alkali metal sulfide. So sodium sulfide is the most soluble. So the correct answer should be either 3 or 4. You can rule out 1 and 2. copper sulfide versus zinc sulfide, which is more soluble if you see. In the same period, zinc comes next to copper. Okay. So along the period, when you move from left to right of the periodic table, the effective nuclear charge of the metal ions increases. Effective nuclear charge means charge to size ratio. Okay. As you move along the period, size of the ions will decrease. That is, zinc ion is smaller than copper ion. So the effective nuclear charge of zinc ion will be greater than that of copper ion. As a result, solubility, you see, the solubility is directly proportional to effective nuclear charge. If effective nuclear charge is more, solubility will be more. So the solubility of zinc sulfide will be greater than solubility of copper sulfide. So the correct answer is option 4 for this question. Look at the next question. Concentration of Ag plus ions in a saturated solution of silver oxalate is 2.2 into 10 power minus 4 molar. Solubility product. They have given solubility and they are asking you to calculate solubility product. First you write the equation. Now solubility value is given. Concentration of Ag plus ions 2s and s as per the stoichiometry. 2s value is given 2.2 into 10 power minus 4. So s will be half of this 1.1 into 10 power minus 4. Solubility product formula for this stoichiometry is 2s power 2 multiplied by s, which is 4s cube. You know s value is 1.1 into 10 power minus 4. Just to substitute here, you will get the solubility product value as 5.3 into 10 power minus 12.